Welcome to the Data Hall YouTube channel. We are continuing our lecture on panel data analysis. This is our fourth lecture on the panel data analysis. We have already discussed the theoretical aspect of pooled, fixed effect and random effect. We have also discussed how do we apply this in Stata. And then we discussed the time or industry or country dummies or year dummy that we used in panel data analysis. In this video, we are going to continue our lecture on panel data analysis. So in our first lecture, we discussed certain models like pooled OLS, fixed effect, random effect. But we didn't discuss the between estimation, the within group estimation, and the first difference estimation. So in this video, we are going to just focus on these three types of models. And do remember that in our first video, when we discussed fixed effect model, we just discussed the least square dummy variable transformation. So there are different types of transformation that we can apply to eliminate the individual heterogeneity, and least square dummy variable method is one of them. And we also have within group estimation and first difference estimation. They both would remove the individual heterogeneity. They all are called fixed effect models, and they would produce exactly the same result. So whether you use least square method, within group, or first difference, the result would be same. So let's start with between estimation. The first step that we do in between estimation is we take the average of all the dependent and the independent variables. And then we run the regression, the simple OLS regression on the averages. So when we take the averages, we have collapsed the data, right? Hence, we have a cross-sectional data instead of panel data. So let's say we have used this model in our first video. We have stock prices as a dependent variable, and we have return on asset and leverage as independent variables. See, we have IT over here as a subscript, and that means we have panel data. In between estimation, what we do is we take the averages of stock prices over different cross-section. So let's just say if we have 3 firms and 10 years of data, so for each firm, we would collapse the data over time. And for each firm, we would have a single value of stock price. The same goes for ROA and leverage. And this can be understood using this subscript. So now we have collapsed the data and we just have a cross-sectional data. We just have I over here and not the T. That represents the time dimension had been collapsed. So once we have the averages, we would just execute the simple OLS regression on the cross-sectional data. Now this method is rarely used, and one of the major drawback of this data is that this method is that it loses the richness of the panel data. So you have collected a panel data and then you collapsed the data and converted it into cross-sectional data, and hence you have lost the time dimension and the richness of the data that you already had. So it is a rarely used method. Let's move to first difference estimation. It is a type of fixed effect model. Now in our first video, we discussed that the issue with pooled OLS is that we have this alpha I, which represents the individual heterogeneity. And if this alpha I is correlated with any of our independent variable, and then we have this problem of endogeneity, and hence we do not fulfill the regression assumptions. So hence we have to deal with this alpha I. So how does in least square dummy variable method we convert this alpha I into dummy variables? But in first difference estimation, what we do is we take the first difference of the dependent and the independent variable, and the first difference is just the difference between the lag and the current value. So it would be stock price T minus 1 minus the current stock price. And then we run the OLS regression on the first differences. So let's say we have this equation, which is YIT, our dependent variable. We have a panel data, which is represented using IT. And then we have this individual heterogeneity. Those time invariant variable that we haven't controlled would represented by this alpha I. And then we have random error. So what we do is we take the difference of all these variables, right? And when we take the difference, how do we take the differences? That I'm going to discuss in our next video related to stata. But when we take the differences, what would happen is that all these variables are in panel form, so they have a time dimension with them, but this alpha I, which is a time invariant variable, do not have a time dimension attached to it. So when we take the first difference, so that would be, let's just say this alpha I is a number 5, so that would be 5 minus 5, and hence these two values cancel each other out. So what we have done is we have eliminated this individual heterogeneity using this first difference method. Okay, so hence our equation would not have alpha it. So one way to remove this alpha it was to use dummy variable. The second method is to use first difference estimation. We take the first difference and that would remove this alpha I. But do remember that as the issue with the least square dummy variable method is we cannot use time invariant variable. So let's just say we want to study the impact of gender on salary. Then gender is a time invariant variable, or race or color is a time invariant variable. So that won't change over time, and hence we cannot study its impact if we are using the first difference estimation or we are using a least square dummy variable. One major drawback also is that we lose lots of observation because we are taking differences. So for each cross section we are losing a single observation. So if we have 100 cross sections, that means we would lose 100 observations. Okay, so next method is to use the within estimation, and within estimation, what we do is we take the average of the dependent and the independent variable over time. So as we did in between estimation, but we move one step forward and we deduct these averages from the relevant variables. And then we, this method, the step 2 is called demeaning a variable. And then what we do is in step 3, we run the simple OLS regression on these time demeaned variables. So let's just say we have this equation over here, we have this alpha I, and what we do is we take the averages of these variables and we deduct these averages from each observation. So instead of collapsing the data, we do have a panel data as opposed to the between estimation, but we deduct the mean from each value. And by doing so, remember the mean of a constant is also a constant, right? So by doing so, we are eliminating the individual heterogeneity from the model, right? But again, the issue within estimation is that we cannot use time invariant variable. And do remember that whether we use the within estimation method, transformation method, or we use the first difference transformation method or the least square dummy variable, the coefficient or the result of these methods would be same. So in our next video, we are going to apply all these 3 methods using stata. Thanks for watching this video. Do subscribe to this channel and do hit the bell icon.